What's up, you freaking geniuses? So in this video, I'm going to teach you all about polygons. So I'm going to teach you what a polygon is and isn't. And I'm also going to teach you about regular polygons and convex and concave polygons. All right, so first of all, what is a polygon? So a polygon is just a flat, closed shape made up of only straight lines. Okay, and those lines cannot intersect. They can't run through each other. So this triangle, is this a polygon? Yes, it is, right? Because it's just a closed shape made up of only straight lines. Same thing with this square. The square is also a polygon because it's a closed shape made up of only straight lines. This circle is not, all right, not a polygon because it's not made up of only straight lines. Okay, this shape over here kind of looks like the state of Nevada. Now, is this a polygon? No, it's not. So it's made up of only straight lines, but as you can see, it's open, right? It's not closed. So no, this is not a polygon. Now, what about this shape down here on the bottom left? So this is a closed shape made up of only straight lines, right? So this is a polygon. What about this guy right here? Is this a polygon? No, it's not, right? Because it's a closed shape, but you can see we have this curved line right here, and polygons don't have any curves to them. So no, this is not a polygon. Okay, what about this next shape? Is this a polygon? Well, it's made up of only straight lines. It looks like it's a closed shape, but as you can see, we have two intersecting lines, right? We have this line intersecting with this line. So you can't have two lines that cross each other like that. So this would be a no. This is not a polygon. And what about this one over here? Well, it looks kind of like a closed shape, right? It's a cube, and it's only made up of straight lines. But again, polygons are only two-dimensional, not three-dimensional like this one, okay? This is not a polygon, so no. All right, now let's talk about regular polygons. All right, so regular polygons are just shapes or polygons that have all the same angles and side lengths, right? So if we're talking about this triangle right here, we can say that this side, and this side are all congruent, or in other words, they're all the same length, okay? And then I'm also going to tell you that this angle is the same as this angle, and it's also the same as this angle, right? So you can see we have all the sides, all three sides are the same length, and all three angles, interior angles, are the same angle, right? These would all be basically 60 degrees. So this would be considered a regular polygon. And more specifically, we would call this an equilateral triangle, all right? Now, what about this other triangle? Would this be considered a regular polygon? Okay, so this might look familiar. This is known as a right triangle. So we have a right angle here, and then this angle is the same as this angle. These are basically both 45 degrees, and then this side is the same length as this side, but here we have a hypotenuse, which is a different length. It's actually the longest side, right? So this side is a different length than these two shorter sides, right? So is this a regular polygon? No. All right, what about this six-sided shape down here, a hexagon? So you can see all the sides are the same length, and all these interior angles are also the exact same angle. So yes, this is a regular polygon, and more specifically, a regular hexagon, right? What about this hexagon over here? So you can see we have, right, 1, 2, 3, 4, 5, 6, right? 6 sides still. So is this a regular polygon? No, because all the sides are not the same length. All right, and what about this last shape right here? Well, this is technically a hexagon also, right? We have 6 sides here. 1, 2, 3, 4, 5, 6. And I'm also telling you that all these lengths are the exact same lengths. So is this a regular polygon? No, it's not, right? Because all the interior angles are not the same. All right, now lastly, let's talk about concave and convex polygons. So first of all, a concave polygon looks like it has a dent in it. And that's normally because there's at least one interior angle that is greater than 180 degrees. Now, for a convex polygon, all the interior angles are less than 180 degrees. Okay, so let's start with this one on the top left. Is this concave or convex? Well, as you can see, it kind of looks like a square, right? I could close this right here, and then you can see it's kind of a square, and then it looks like it got kicked in through on the side over here, and then it kind of created a dent, right? So this would be known as a concave polygon. Okay, so that's one way to kind of notice a shape by the dent. Now, I also said it's going to have at least one angle that's greater than 180 degrees, right? So with this shape, you can see, well, this is a 90-degree angle, this is a 90-degree angle, this is an acute angle, this is an acute angle, but then this angle right here, this angle is greater than 180 degrees, because 180 degrees would just be a straight line, right? But as you can see, this basically reaches back further than just a straight line. It goes all the way around like that. Okay, one other way that we can actually identify concave polygons is if you start in any corner of your polygon and then you just draw kind of like this imaginary line to any other corner of the polygon, it's going to go somewhere on the outside of the shape, right? So for example, if I started in this corner over here and then I just kind of drew like this imaginary line to any other corner of the polygon, did I go outside the shape over here? No, I'm right on the line, right? I'm right on the shape. So that's fine. What if I drew a line from this point down to this corner over here, right? I'm still inside or on the shape, so that's fine. What if I drew a line from this corner to this corner down here? Well, you can see I'm going to go outside of the shape, right? So if you ever end up drawing a line outside of the shape, that's just another way you can identify a concave polygon, right? So there's a few different ways that you can figure it out. Now, what about this next shape right here, this star? Is this a concave or convex polygon? Well, again, you can see that it kind of looks like it got kicked in, right? It kind of got kicked in there and here and here. And you can also see these angles right here are greater than 180 degrees. And again, another way we can do it is just by drawing those little imaginary lines. So if I drew a line from, let's say, from this corner to this corner, you can see, okay, that's fine, I'm good there. But what if I drew a point from here to here? Okay, well here, I'm going to end up outside, right? So then we know that this shape, this star, is concave, right? And again, remember this one was also concave. Now, what about this one over here, this parallelogram? Well, you can see these are acute angles right here, and then these are obtuse angles, right? But they're not bigger than 180 degrees. So all the angles in here are less than 180 degrees, right? And again, if I did my imaginary line test, I could start here and draw a line to any other corner. So these are my other corners over here, right? I could draw that imaginary line to there. I could draw it to this corner, or I could draw it down to this corner, right? Do I ever end up outside of the shape? No, I don't, right? I always stay either inside the shape or right on the shape, right on the sides. So then we can tell that this is simply a convex shape, all right? What about this last one right here? Okay, well, it kind of looks like maybe there was a dent here. We also have these 90-degree angles right here, okay? But what about these angles? Well, these angles are not 90 degrees. These are actually 270 degrees each, right? Which are obviously bigger than 180 degrees. And again, for good measure, you could just start at one point and draw your imaginary lines to any other point or corner on your shape, right? So if we drew one from here to here, we're still on the shape, that's fine. What about from here to here? Oh, well, there we went outside the shape, right? So then here we can obviously confirm that this is a concave polygon. So if you found the video helpful, definitely leave a thumbs up down below. And if you have any other questions or want to see any other examples, just let me know in the comment section below.